Good day. Today we will continue the theme elements of symmetry of crystalline structure. We will tell about the screw axis of symmetry and theorems of the combination. The screw symmetry axis is a set of the axes of symmetry and the parallel transport to it acting together. Screw axis of symmetry characterizes, for example, the arrangement of flex spike scales. The hexagonal knot has a screw axis of the sixth order. By analogy with simple axes, the helical symmetry axis can be only double, triple, quarter, and hex. There is no screw axis of fifth order, the simple axis. This axis is impossible. For example, 4, 1. The large number indicates the order of the axis, the quotient of the index, in this case 1, by the large, in this case 4, in other words, 1 derived 4, and gives the amount of transfer along the axis expressed through elementary translation along this axis. Of course, the action of screw axis is more complicated, but you can see a lot of examples of screw axis in surrounding environment or nature. The next step of our lesson, the theorems of combination. Earlier, for the symmetry elements of the crystal, it was shown that a combination of two symmetry elements always generates a third symmetry element. This is the base for deriving 32 symmetry classes of a crystal, or in other words, point groups. With the combination of symmetry elements of infinite structures, exactly two symmetry elements lead to the appearance of the third. A complete set of symmetry elements of the structure is a spatial or Fedorov symmetry group. There are 230 space symmetry groups. They are derived on the basis of theorems on the combination of symmetry operations of structure. Here you can see an example of the theorems. For example, theorem 1, the simplest, of course. Sequential reflection in two parallel planes of symmetry is equivalent to translation to the parameter t equal to a, where a is the distance between the planes. There are several such theorems, and of course they reflect possible combinations of symmetrical transformations of structure on the basis of which a variety of the spatial groups is obtained. The term in spatial or Fedorov groups are the same as the class symmetry for the crystals. But if you remember, there are only 32 classes of symmetry, but there are 230 spatial groups or groups Fedorov are known now. And there are I repeat that the spatial symmetry group characterizes the crystal structure symmetry in the same way as the point symmetry group characterizes the symmetry of crystal external shape and its physical properties. To each point group there are corresponding several special groups. In the next lecture we will tell about the special symmetry groups or regular system of points. They are the equal definitions. Thank you.